Okay, so we are going to be proving the homogeneity of question 1, question 2, and question 3. All this in basically 5 minutes. Okay, so this is A-level physics, so I'm not going to be doing much of the explaining. Okay, so question 1 is basically Coulomb's law. Force is equal to 1 over 4 pi epsilon naught times Q1 times Q2 all over R squared. So I'm just going to take a blank sheet and we get started with question 1. So I've written question 1 on a clean answer sheet for working purposes, right? So we're going to prove the homogeneity of this equation using base units, right? The base units. Okay, so what is the unit for force? The unit for force is newtons, which is equal to, so if you notice 1 over 4 pi is a constant, of which a constant has no units, so we leave it out. So the unit for epsilon naught, which is the permittivity of free space, is newtons meter squared over coulomb squared. Right, keep this in mind, right? Then the units for q stands for charge, right? And we have q1 times q2, which is q times q, which will lead to q squared over r squared. R is the distance between the charge. Distance is measured in meters, so the unit for r will be meters. So in this case we have r squared, obviously is going to be meter squared here. Further simplification, you will see that m squared will cancel m squared, then coulomb squared will cancel coulomb squared here, leaving us with Newton equal to Newton, right? At this point, the homogeneity of the equation has been established, right? But the question is demanding to prove the homogeneity of the equation using base units, right? Using the base units, Newton is not a base unit, right? So what is the base unit for newtons, right? So we know that F force is equal to mass times acceleration, right? What is the unit for mass? The unit for mass is kgs. What is the unit for acceleration is meter per square second, right? So what is the unit for force? The unit for force is Newton. So N is equal to kg meter per square second, right? So we have N equal to N, which is mathematically correct. So we are now substituting kg meter per square second. We are now substituting N with kg meter per square second, right? So kg meter per square second is equal to kg meter per square second. You're done now. Basically, you've proven the homogeneity of this equation using base units. So we've moved on to question 2, which is saying that nu is equal to A rho times T minus B rho over T, right? Rho stands for density. Then nu stands for viscosity, right? So A and B are constants, right? What do we know about constants? Constants have no units, they have no dimensions, right? So let's attempt to prove the homogeneity of question 2. Okay, so I've written question 2 on a separate answer sheet for working purposes. That we know that viscosity, the question is saying that viscosity is equal to A, which is a constant, times rho times time minus B, which is a constant again, times rho over T. Rho is density, right? So let's start substituting the variables with their units, right? So nu is for viscosity, right? So viscosity is the unit for viscosity is Pascal seconds, right? Of which you know that Pascal is the unit for pressure. So 1 Pascal is equal to Newton area which is in meter squared, right? So what is the base unit for newtons? We know that newtons is equal to mass times acceleration. So the base unit for newtons is equal to kg meter per square second. This is the unity for newtons, the base unit for newtons, the base unit for force, right? Over meter squared, right? But we are not done yet. We are not done yet since nu viscosity is equal to Pascal seconds, so times S here, seconds, right? So your A levels, I'm not going to be doing much of the explaining here. So I'm going to simplify this expression, okay? So even an O-level student can simplify this expression. So if you simplify this expression, will lead to nu will now be equal to kg per meter per square per second. If you simplify this expression, it will lead to kg per meter per square per second, right? Kg per meter per second. So let's substitute kg per meter per second into the equation now, because we want to prove the homogeneity, right? So nu is equal to kg meter per square second, right? Equal to A is a dimensions constant. Then rho is density. The unit for rho is kg. The cubic meter. Then T is for time. The unit for time is seconds times S. Then minus B is a constant, is no units. Then rho is density again, which is kg cubic meter, over what? Over T. T is what? T is time, and it's measured in seconds again, right? So we are at this point in the expression. So further simplification again, we make like this: kg per meter per second equal to kg per cubic meter seconds minus, basically, over S is kg per cubic meter over S. This expression is the same as kg cubic meter per second, right? So if you take a look at this equation, it is not dimensionally consistent. We have kg per cubic meter per second here. We have this is kg per meter per second here. Then we have kg per cubic meter times seconds here, and also we have minus kg per cubic meter per second. So this term is almost the same as this term, only that there's a cubic meter here. So therefore, none of these terms are the same. So when you're proving the homogeneity, everything in the equation should be the same. Therefore, this equation is not homogeneous. This equation is not homogeneous, right? So we are moving on to question 3 now. Question 3 is a bit interesting, so be patient and work with me. So question 3 is saying that which of these equations relates V, the velocity, and A, the width? A is not area now, it's width. Then density, rho, and nu, the viscosity, correctly. So we just need to prove which of these equations, A, B, C, is homogeneous. Okay? So we'll start by A. If A is not homogeneous, we move on to B. And if B is homogeneous, we are done. So, but if B is not homogeneous, we move on to C. Right? If none of the equations are homogeneous, therefore our answer is none of these equations. Right? So let's start proving the homogeneity of these equations. Okay, so these are the equations. I've written them on a clean sheet. So this is equation A, equation B, and equation C. So I'm just going to prove the homogeneity of each equation in each row, right? So pay very close attention. So equation A, V is equal to A nil A over rho. Okay, so this A is standing for width, nil is standing for viscosity, then V is standing for velocity, right? Then rho obviously standing for the density. Then A, B, and C, these are constants, right? So, okay, so let's start substituting with the variables with their units, right? So, V, the variable for V, the velocity is meter per second, right? So, meter per second is equal to, the meter per second is equal to, A is a constant, which means it has no units. Then nu, the base units for nu is kg per meter per second, right? Then A is for width. What is the unit for width? Is meters. Then rho, the unit for rho density obviously is kgs per cubic meter, right? So this part is clear to everyone, right? We've only substituted the variables with their base units. So no simplification has been done yet. Okay, so let's start simplifying now. So kg, we cancel out kg, right? Then leaving us with meter per second equal to m to the power negative 1, s to the power negative 1, m over meter to the power negative 3. Right? So this cancel out this, right? Your A levels, I'm not going to be doing much of the explaining. So m per second, so m meter per second is now equal to per second over cubic meter, right? So we know that this is not the same, right? If you look at the equation, meter per second is never equal to a second over per cubic meter, right? So let me just write this neatly here. Second per cubic meter. Therefore, equation A is not homogeneous. Equation A is not homogeneous, right? So let's move on to equation B. equation B, we have v, the velocity. Again, the unit for velocity is meter per second. Then we have meter per second equal to b is a constant nil kg per meter per second. Nil is viscosity. The base unit for viscosity is kgs per meter. It's kgs per meter per second, right? Then A, according to the question, A is not area. A is length. The unit for length is meters. Then rho obviously is the density, right? Density, which is kg per cubic meter. All right. So at this point, we have not done any simplification. The simplification is starting now. If we simplify, if we start simplification, m meter per second is now equal to kg. We cancel out kg initially, leaving us with per meter per second over meter times the cubic meter, right? Simplification of the denominator will lead to m per second equal to per meter per second. You know that dot means we are multiplying, right? So m is basically m to the power 1. So the simplification of this will lead to m to the power negative 2, right? So basically this is the same as meter per second equal to per meter per second over 1 over meter squared. Okay, so keep this in mind. So basically what I've done here is that m to the power negative 2 is just the same as 1 over m to the power 2, right? Okay, so if you're a physics student, you must be used to mathematics, right? So m to the power negative 2 is just the same as 1 over m squared, right? Of which, if you look in the expression we're simplifying, we had m to the power negative 2 in the denominator, right? And we have m to the power negative 1 s to the power negative 1 in the numerator. So the numerator stayed the same for the moment, which is m to the power negative 1 s to the power negative 1. Then the denominator, which is m to the power negative 2, is the one we have simplified to 1 over m squared, right? Further simplification here will lead to m to the power negative 1 equal to m squared times m to the power negative 1 per second, right? Okay, so so which means this denominator will somersault and will end up in the numerator, and we'll be left with no denominator, or 1 is the denominator, right? 1. So basically 1 is basically, we can just leave it out, right? So m per second is now equal to simplification of m squared times m to the power negative 1 will lead to m, or m to the power 1, which is basically m times what? Simplification of this, m squared times m to the power negative 1 will lead to m, then times what? Times per second times s to the power negative 1. So if you look closely, m per second is now equal to m per second. Meter per second is now equal to meter per second, which means that equation B is homogeneous. Equation B is homogeneous. So if equation B is homogeneous, it can be used, right? It can be used. I'm looking for the question now. I can find the question. So basically, equations A is not homogeneous. Equation B is homogeneous. So we are not going to prove the homogeneity of equation C, since we've already found our solution. And we're done.